What if I told you that you don't have to 100% rely on the LangChain provided agent executor object to create LLM agents? Yes, you heard it right. In this video, we are going to create agent executor logic by ourselves. In the last tutorial, we saw how we have implemented the LangChain provided AI agent and agent executor to implement a simple agentic flow and also MySQL connected agents. But the problem was the agent executor was not performing up to the mark in all cases. There were instances where it was hallucinating and it was doing wrong LLM calls. So I promised to bring forward an approach how I can implement the agent executor from scratch. And here it is. In this tutorial, I will show you how to implement your own agent executor. Okay? Without wasting any time, let's deep dive into the hands-on coding and see how AI agent executor would be implemented. Okay, let's get back to our basics from the agent orchestration that we just visited in the last tutorial video. So in this tutorial, we are going to explore how we can build the AI agent executor from scratch. We observed some drawbacks in the last approach, or rather there are some hallucination problems in the agent executor that we have as a part of the provided framework in LangChain. And so I promised that I would be bringing up a new approach how to orchestrate the agent executor by scratch. That is something, again, the syntax is provided by the LangChain framework. So this is a quick brush up of what is the under the hood. We have the chain of thought prompting. I have had a detailed discussion in the last tutorial video. Just go and watch that. You would get a good overview. But in brief to say, so in the background, chain of thought prompting combined with the ReAct reasoning and action is what are AI agents internal orchestration. So the ReAct algorithm, how it works now to the LLM agent, when the user supplies a query, we prompt it in such a way that we instruct it to think first. That is the thought. Now in that thought process, we ask it to choose which tool it needs to execute the next step. You know, for an agent that is not trained with a particular domain, domains may be retail, education, or healthcare sector. There are multiple areas where we would orchestrate agents. It can be a scenario that the agent is not having the knowledge that is relevant to that particular domain. So in that case, as a programmer or developer, we would expose some built-in functions as tools to that agent. Whenever a query is asked to that agent, the agent should be capable to think which functions it needs to call to get the relevant amount of information that is required to arrive at the final answer. And this step will not be a single step. This can be an iterative dynamic process. So, if I expose a set of tools to that LLM and ask it to think in a step-by-step manner, identify which tool to execute, and you get a chunk of information. Now you reflect on that output. Can you give the final answer? Okay or not okay? If you are not okay, then again think whatever information you have at hand, you think, and again, if required, choose a tool to orchestrate. And on executing that tool, you get a response as output. Then again, you reflect and think, I have these answers. This is the query. Can I conclude to the final answer? Okay. If not, again iterate. And if I get all the responses and I am sufficient enough to answer the final response, then the agent would give us the final response. So this is the overall working of that AI agent. So it runs in a loop. We would orchestrate the agent executor similarly with just a while loop. Before that, let me show you what drawback we were observing. So I would quickly open the last project that I have done as a part of the last tutorial. This is also uploaded in the GitHub. You can find that in the description of the video of the tutorial. I have linked that tutorial in the description as well. So there we had two files, main.py and main with SQL tools.py. So there were basically two hands-on. One hands-on was a simple POC where we had tools handling the string. This method was returning the length of the string upon sending a string. This method was returning the number of vowels upon sending a string. And I exposed this as tool, @tool, a decorator from the LangChain. And then I provided those as a tools to the agent. So I have used the create ReAct agent from LangChain, and there I have sent the tools, and this was the LLM object that we had created. The detailed explanation is provided in the last tutorial video. Now I am just focusing on the drawback. So this is the ReAct template prompt. When I supply the prompt, supply the LLM and the tools to that agent, and using the AgentExecutor object provided by LangChain, if I orchestrate that AgentExecutor with this query, what is the length of peacock? Now let's run and see what is the output of that AgentExecutor. And we will try with numerous instances and see what was the final answer. So we saw that the length of peacock is 7. So this is correct now. If I change the string to bismuth and try. We have to try with different prompts and see, is the behavior consistent? Is there any hallucination problem? I am getting a consistent answer because, okay, I remember. I added these two lines. If we go back to that tutorial video, you would see that I added these two lines because the agent was hallucinating. These two lines I added on the top of the ReAct template provided by LangChain Hub by Harrison Chase. So I added these two lines explicitly because the agent was not performing. It was doing one step further. Even if it has reached to the final answer, it was running other tools as well. It was hallucinating. What I would do, I would remove these two lines and show you if there are any problems with the behavior. Let's see how the agent behaves now. The query was find the length of the string alphabet. Now see, the agent started with finding the action that it needs to execute the function get text length. That is fine. It got the final answer. Again, it is reflecting and it had got this question out of nowhere. I didn't ask as a user, how many vowels are there in the word hello? This is a hallucination problem. The agent is hallucinating. I didn't provide as a user, but then also this problem is occurring. Why? My final answer was just 8, but it is not showing like this. So in order to avoid that, in the last tutorial, what I did, I added these two lines to avoid this situation and make the agent work correctly. So this is something, a hint of prompt engineering you are getting to see. In real life use cases also, you need to tweak the prompts in wherever you are implementing in your work or in your college projects. You have to do a bit of prompt engineering whenever you are dealing with generative AI projects. Keep that in mind. So The second problem is, one was the hallucination problem. The second problem was, I am not able to control whatever is happening inside the agent executor. It is as if a black box. The programmer doesn't have a control to see what is happening inside agent executor. The loop that I was talking about in that architecture diagram of ReAct algorithm, the loop was running, right? How many times the loop will execute? We have set it here as max iterations as 5. We are limiting the iteration. There can be scenarios where we don't want to limit. And that is possible with agent executor object provided by LangChain, but we don't have the control inside that black box. If we want to monitor and monitor the each of the steps of the agent, then that is not possible with full comfort with this. So now we would implement the agent executor from scratch. Okay. Let me first create a folder. I am doing this from the beginning so that you guys can get a good overview of how to make that from scratch. AI agent from scratch. Okay. I hope that you know what is a peepenv. Peepenv is used to install the dependencies a very lucid manner. If it's not installed in your system, then do a install peepenv like this, and your peepenv would get installed. Now once that peepenv is installed, whenever you are starting a new project, you write peepenv shell to create a virtual peepenv environment. You can do this with Python virtual environment, but the advantage with peepenv is it creates a peep file and a log file, much similar to the package log.json that we have for front-end projects. Okay, so the peep file has got created. You see here we have got the peep file. Now we have to install a couple of dependencies that we require for our project. So that is LangChain, OpenAI, Black. So I would install that first. Peepenv install the LangChain, OpenAI, Black, OpenAI, sorry. I am installing OpenAI, installing the Black, installing the Python .environment to pull the environment variables. Okay. The LangChain OpenAI to connect with the LangChain library wrapper over the OpenAI. And the MySQL connector I don't need for this project because I am not dealing with the database. I am doing a simple POC with string methods. Okay, that was for the last project what tutorial I have posted making SQL agents. If you are interested in that, please do visit that video and learn. The description has that link of that video. Now the dependencies are getting installed. You can brew a coffee. Meanwhile, you can also pause the video and set up the code base in your system and follow my steps. Then it would be very easy. You know, whenever you are doing some project, hands-on learning is the key because it makes you learn so many things. And great experts also say that hands-on learning is superior to anything, and that is valued across industries. So the installations has been completed. Now I would quickly open the project that we have just created. Okay. Let me open that. It's under the LLM projects. I'm navigating to that. Oh, the one that I have just created, agent from scratch. Okay, this one. Okay. So on importing that project to the PyCharm, automatically PyCharm has detected that we have the peep file and we need to set up a peepenv environment, right? So let's make that work, and automatically we would get that pip file being installed. Okay, so I would create a Python file, that is main.py, and I would also create a callbacks that would be utilized to log different situations when we are using LLMs. Callbacks.py. Now in the callbacks.py, what I would do, I would implement the base callback handler from the LangChain. So basically LangChain provides a system that allows us to hook into various stages of the LLM application. Basically we use this for logging, monitoring and streaming different events or different situations. When the LLM is starting off, then we can log something that the LLM has been triggered with this prompt, or when it responds back we can log something. So basically it's going to help us to hook in different stages. So I would first create that callback. So you see, from LangChain callbacks.base I am importing the base callback handler, and I am creating my own customized agent callback handler that is inheriting the base callback handler, and I am overriding the LLM on LLM start method. Whenever the LLM is started, then I would print the relevant chunks of information. When the LLM is about to end, the response is being concluded, then this method would be triggered. So this is mainly for logging and monitoring. This file is for logging and monitoring at different stages of the LLM. You can use this for logging anything. So this is a simple explanation, a simple implementation of introducing the callbacks. Okay. So now in the main.py, we would first load our environment variables. Now in the environment variable, what I have to place? I have to place the OpenAI key. So I would create a .env file where I would put the OpenAI API key. Okay. This key you are going to get it from the OpenAI dashboard. If you have a subscription in the OpenAI, then you can use that. You have to create a key and copy that key and put that here. Without this, the LLM calls would not proceed. Okay. Now this load.env would automatically pull off those environment variables that I have placed in .env file. Okay. Now what I would do, I would create two tools. Tools are nothing but functions, right? So let me import the tool. This is from the LangChain. I doubt I would copy the wrong one, so let me import the langchain.tools. Okay. Okay, fine. So see, here are two methods, string handling methods. I have given an input string. This method would return as a length. I am annotating this method with @tool to explicitly mention that this is a LangChain tool. Similarly, I have written a method that would find number of vowels in a given string. Keep in mind that these descriptions are very important. In LangChain tools, the function description is being read by the LLM calls. The LLM reads this description and identifies what this function does and decides based on that description whether to call that function or not. So make sure you are providing function description very accurately. Okay, so these two methods are provided. Now let me create a list of those two tools, get text length and the get number of vowels. Okay, the tools array is being declared. Next, let me copy this code and explain you. So it would save some time. see, these tools are already here. Fine. Okay, this template is from the ReAct template provided by LangChain. So please understand this prompt, how I am instructing the agent. See, answer the following questions as best as you can. You have access to the following tools. In curly braces, we are supplying the tools. Here we would substitute whatever tools we have. Basically the get text length and get number of vowels. And then I am instructing that you should think in this following format. There would be a question that the user would be supplying, the input question you must answer. Then you have to find out the thought. You should always think about what to do. You have to identify what action you need to take among the tools provided, the tool names. Tool names would be the function names here. So among these, you have to choose which action you need to take, and also identify which action input you have to send. From the query, you have to identify what would be the input data to those action steps. And upon identifying this, the next step would be to invoke that function with that action input and get that observation, the result. And this can be repeated n number of times. Then if you get all the intermediate answers that are required to achieve the final answer, then you should conclude and say, I now know the final answer, and the final answer is this one. So this is the structure of the thoughts, the thought processing, the chain of thoughts pattern. And then after beginning the question, I would substitute the input with my input question, and in the thought I would upload the agent sketchpad. Now this agent sketchpad is very vital. Whatever steps the LLM is taking, there would be multiple steps, right? It would run in iteration. In the first call, the LLM would identify the thought, the agent action, the action to be taken, the output of that action. Okay? Again in the second call, it would again think, find that action input, execute and get the output. So the agent sketchpad is basically the record of all the intermediate past steps. Each time the LLM is called, the LLM has the ability to see what the previous calls were about. What was the question, what was the action input, output, the response of that action, result. So it is able to see what the previous steps concluded. So it would help it to decide in a better way, and it would avoid duplicate tasks. So agent sketchpad is the placeholder where we would supply the previous intermediate steps with all the action input, observation, all those steps together. Okay, that was all about the prompt template. Once that prompt template is done, we would create the prompt and the OpenAI LLM object. This render text description is a utility method provided by LangChain. I am creating a prompt template from the template, this one. There are placeholders, so I need to partially fill, because some values I am filling here and some values like the input I would fill at the last. Okay. Now see, in the tools, these tools would get substituted with a value, and that value is this one, render text description, where I am sending the LangChain tools array, this list basically. So in the render text description, what we have in this utility method, this is already provided by the LangChain. See, it is a library. It is inside LangChain core. So what this method does, it renders the text, the method name and the description of that method or the tool. It extracts the description and it formats in this type of format where the tool name is followed by the tool description. Okay. So this is basically going us to give a text where each line contains the tool name, the function name, followed by the description. Means for our case, it would be get number of vowels hyphen return the number of vowels in the string provided as input. So that is the work of this render text description already provided by LangChain. And the tool names, I am just extracting the tools and chopping out the name joined with comma. So comma separated name of the methods is basically the tool names that would get substituted here in that prompt template, right? Once that prompt template is created, I would create the LLM object. I would use the chat OpenAI. This object would automatically use the OpenAI API key that I have in the .env file. I'm setting the temperature to 0 to make sure that the LLM doesn't think out of the box and makes the things very inconsistent. I want to stop that, so 0 is very promising. Now this stop equals to the stop token. Why I am applying this stop token? The reason is when the LLM would start thinking, then it would find the action and the action input. Then this observation would not be the task of the LLM. This observation we would orchestrate in the AgentExecutor and invoke that function, get that output, observation result, and we would plug that in the agent sketchpad. So the LLM must stop its flow whenever this observation is rendered. I want to stop the LLM generating any text whenever this observation is reached. So by that way, I would not enable the LLM to identify the result of the action. It should not hallucinate. I want actual result. So at each LLM step, I would obstruct the LLM to go further this observation token. That is the stop token. That is why I have put that as stop, either \n observation or simple observation. Because in many cases we can have that /n then observation token. So I want to stop the LLM thinking and generating context or text whenever this observation token is reached. Once that observation token would be reached, means our code would automatically identify the action and the action input and call that tool or function and provide the result programmatically, not generated by the LLM. So that is the purpose of this stop token. And these callbacks we just created here, and we would plug that to that LLM object. So whenever that LLM is starting or concluding, the callbacks would be respective callbacks would be triggered and respective messages would get printed. Okay, so that was the creation of the LLM object. Now next, we would create the agent object and the agent orchestration logic. Let's do that. Okay. See, now we are here. This intermediate steps is just for recording the previous LLM steps so that we can render that agent sketchpad. You remember we have this agent sketchpad that is containing all the previous steps that the LLM has thought of, observed and invoked. So we would store those steps in intermediate steps list. Now I am creating an agent. So this agent creation is different from the one that we used in the previous tutorial, where we used the create ReAct agent method provided by LangChain. Instead of that, we are using a special syntax. This syntax is called the LangChain expression language, LECL. This expression language helps us to create agents in a declarative approach. There are many syntax. We can use pipe operator to plug in the components of a agent. If we go here, we see the first part is the prompt input part, because in the prompt we see that we have the prompt here. These details are already plugged in, the tools and tool names with partially. But this agent input and the agent sketchpad are not substituted. So that input I must provide. So in the input, what I am providing, so whenever the agent would be invoked, I would supply an input and agent sketchpad. This lambda function is just copying that input value from that dictionary that I would provide at agent invoke state, and it is storing in the input. And also that agent sketchpad I am substituting from the agent sketchpad part that I would provide in the agent invoke. This format log to str is also a utility method provided by the LangChain. So basically the agent sketchpad would contain the agent steps, that is an object. That is an object, separate object that would contain complex parameters and fields. But we know that LLM only understands text. So that agent step objects, whatever details we have inside that, we would have the tool name, input, action, all those stuffs. We would format that into a simple string. So that is done by this method. So all the heavy lifting is done by the utility method format log to str. So all the agent step, agent action steps, it is containing a agent action step as a list in that intermediate steps, and it is then converting as a formatted string the observation prefix, then observation, then LLM prefix. So it is containing a text representation of each of the steps. Okay, as a deep observation thought pattern. Yeah. So that is what this format log to str is doing. So this is the input to that prompt. Pipe, whatever is in the left hand side of the pipe, that is plugged into the right hand side. So this input is plugged into prompt. Then that prompt is plugged into the LLM object, this one. Then the LLM object is plugged into a ReAct single input output parser. This is a agent type that would invoke or implement the ReAct pattern, reasoning and action pattern, single input output parsing. Now that was our agent object. Now this agent should iterate, right? The query should be invoked to that agent in an iterative process. So that would be a while loop. That is why inside while loop, until the agent step is an instance of agent finish. So agent step can have two possibilities. It can be a agent action or it can be a agent finish. Okay. So it can be an agent action or agent finish. But when it's an agent finish, that means our loop should stop, because the agent invocation has reached to the final stage, finished stage. Okay. So till that agent step is not an instance of agent finish, the while loop would run. And each of these agent step can be either agent action or agent finish. So agent.invoke, I am invoking the agent with this dictionary. What is the input is what is the number of vowels in a particular string, and the agent sketchpad is the list of that steps, previous steps. Okay. So see, the intermediate steps I would populate that with the with this orchestration code here. Before that, you see initially the intermediate steps is empty in the beginning. Whenever it would get first iteration is over, then there would be an entry in the first entry in the intermediate steps. When the second iteration is over, there would be two entries in the intermediate steps, and that would get concatenated to this prompt, this part. Okay. So what I am doing, this prompt is invoked to that agent that would come here, get parsed, plugged to the prompt, LLM invoked, and then I am getting a agent step. I am checking whether that agent step is an instance of agent action agent actions are the intermediate ones, and the last step where the agent has finished execution would be the agent finish. But if it is in between, the LLM has not concluded the final answer, that is a agent action instance, then what I would do, I would extract the tool from that agent step dot tool property. What tool I need to invoke? We were saying that our agent executor would stop generating any response, the LLM would start generating any response after once the observation token has reached. Once it has identified which tool to invoke, it would be our responsibility to execute that tool. And that is what we are doing here. We are identifying which tool to execute from that agent step, and what tool to use, we should get that. So in order to do that, I will write a method called the find tool by name, where I am simply fetching the tool from that list. So I would paste that code here. What this find by tool name? I have the tool list and I have the tool name. It would simply find that tool in that list and it would return that function. It would return that LangChain tool, LangChain function. So that LangChain function, I am using that to invoke with the tool input. So each of the agent actions steps would have a tool input. Okay. So I have the tool name. I would find the method, tool method. I have the tool input. I would feed the tool with this tool input. That is what we are doing here. We are executing the tool to use .func. This is a method provided by LangChain tool, LangChain. So that method would be invoked. If it's a get the text length, then text length would be invoked with the string. That tool input would be a string then. If it is the get number of vowels, then it would be invoked likewise, right? Whatever we are getting as the output, that is this output, this one, that is the observation of each step. I have printed that observation as well. And I am also adding that in the intermediate steps list. What it is a tuple, agent step and the string version of the observation. So this is a tuple that we are storing in that intermediate steps. And that will be parsed by the format log to str. If you remember, it is a tuple of agent action and string. This is the string. The string is that observation. And this is the agent step, that is the agent action. At the last, when the while loop gets terminated, when the LLM has ran a couple of times, got all the unknowns sorted, now it is able to conclude to a final answer. Then on doing that agent.invoke, the object returned would be of the type agent finish. And then when the while loop condition is checked, then the agent step is an instance of agent finish, the loop would get terminated. Then the control would come here. If it's a instance of agent finish, that means the process is completed, then I am printing the final output from that agent step. I would get the final answer. So this is the orchestration of the agent executor that we have written from scratch. Okay. Now let's run it and check. Please note that I haven't used those two lines. Those lines what I used here, if you remember, in order to omit the hallucination, I use these two lines. Once you reach to the final answer, stop this process. Do not hallucinate on the questions. Think on the question the user provides. I have not used that here because our execution would stop whenever the final answer has been achieved, because our orchestration is from scratch. Now let's observe that with full confidence. Okay. So my query is find the number of vowels in pottery. Okay, so there is a mismatch. Let me import. Okay, all the inputs has been sorted. Now let's run. So it is asking to find a number of vowels in pottery. So which method the agent should choose? It should be this one, the get number of vowels. Okay, let's see. See, the process has ended. So hello React LangChain, this is this print. This one, process has started. Prompt to LLM was this. So this is coming from that callback here. So whenever the LLM is invoked, the call is invoked, that callback method it gets triggered and it prints whatever we are calling whatever we are sending to call the LLM. So this was not available in that previous agent executor, right? We didn't find anything. What was running behind? What prompt was sent to the LLM at each step? What was the output from that LLM? What we were sending in that placeholders? We were not able to see anything, right? That was a kind of black box. But here we are able to investigate and see each of those steps. So that is the additive advantage. See, these are the tools, and that was what I was talking about. That would be the tool name followed by the description. So that is what this method is doing, the heavy lifting for us. So here it got substituted. It got substituted from where? From this render text description method by LangChain. So it is concatenating the tool name with the description in plain text. So that is what we got. So the LLM only understands text, right? So with this, the LLM would be able to map which function it needs to call. So this is a prompt template, React prompt template. Then the question from the user. What is the number of vowels in pottery? Now it is thinking. The LLM is giving a response. I need to count the number of vowels in the word pottery. My action would be get number of vowels, action input is pottery. Please note that observation has not been written. That means the observation, whenever that observation token was going to start, the LLM has stopped because we provided a stop token here, right? We provided the stop token observation. So that is why you are only seeing the LLM response up to action input. Because once that action and action input is identified, it is a single input output parser. So we would directly invoke that method with this input and we would programmatically plug that response, right? Now this is the agent step object. The agent step object has a tool. So this is returned from here. This is the agent step. So when it has got invoked, so the agent step is, it has identified which tool it need to invoke, the get number of two vowels, the tool input it had identified as pottery, and it is in the log we are getting that LLM response. I need to count the number of vowels in the word pottery. Okay, action is invoke this name, get number of vowels. Okay. Now observation is 2. From where it is coming? This is coming from here. We have programmatically find out which tool to invoke and we are invoking that and getting that result. So we are here in the output phase now. In the first iteration, the LLM has found out which action to invoke. We have invoked that tool. We have received that output as observation 1. The first observation, right? Now again in the second time. So before that second time, we are plugging that agent step and observation in the intermediate steps array. Now you would see the magic in the second time. When we are sending the call to the LLM in the second iteration, you see this is fine, this is fine. Here is the magic. So this is coming from that agent step. Okay. So agent scratchpad. So this is basically the agent scratchpad here up to this. This is the agent scratchpad. What is the number of vowels in pottery? I need to count the number of vowels. what is the action, action input, observation. These are all coming from that agent scratchpad. So previous call, results are populated in the second call from that agent sketchpad. Now the LLM is now reflecting. I have already received 2, right? Means I have found out the number of vowels. Do I need to invoke again? No. So now the agent step is of the type agent finish. So there are 2 vowels. It has given a final answer. The final answer is 2. So the agent step is of agent finish. That is why the loop got terminated. And the output was 2 because the final answer it has identified as 2. Number of vowels was 2 only. O and E were there, right? So see, we are able to see what steps were there in each of the LLM calls. It's very transparent. We have the control in our hands. We're able to implement callbacks, do the monitoring by ourselves, and we can track each of the steps. It is very helpful for debugging process. So that is why implementing the agent executor from scratch is very important. If you get this tutorial very helpful, then please don't forget to subscribe and share this with your colleagues or friends. Learn as much as you can. If you have any questions, drop that in the comment section. I am very, very eager and responsive to attend your queries. I would provide the code base in the description link. You can find out from there. You can study from there. Okay. Very soon I would bring up a new tutorial with AI agents or RAG embeddings, RAG invocation. There are many topics in this generative AI world. I would be soon creating more tutorials. It takes a lot of effort to build a tutorial just for you. So it's your turn to provide the Guru Dakshina to your teacher. Share this video with as much people you can. Okay? Have a good day. Meet you in the next video.